Alright, so it looks like we're live. Welcome back. Hello world. We're gonna just hop right into it. So the other day we were working on this problem. We wanted to see if we could time it. Now, we did run into something interesting here. This is a few things to note. Let me set timer for an hour. We did get a handle on how much time this algorithm took locally, and after an hour I'll end stream. We'll figure out what to do next. I think so what's interesting is I've got sorry, just thinking, what are we doing here? Right, so we'll work on just solving this problem first. First I want to just solve it and bring it down to a time that's reasonable. Just solve it in a reasonable amount of time, profile it and whatnot. I did learn about something called the Y Combinator, which is not the company, but the actual lambda calculus combinatorial logic expression, the Y Combinator. It's pretty cool, a pretty interesting thing. I'll probably take a look at that later. Might, after this hour, maybe go into detail. But I was curious about it because it actually gives us a way to perform loops in a functional programming language without using side effects, which is pretty great, which is what we're looking for. Don't have to use the while command to have our execute loops. So we can go back and actually, I might even end up putting it in this program, 4 hour, what's that called? Well, I guess, yeah, for our stack-based algorithm, we can implement the Y Combinator, and then for the binary search algorithm, we can also implement the Y Combinator, and in both cases we can get. Is it this one that has the binary search? No, it's not this algorithm. There's another algorithm that we were looking at, binary search. But yeah, we can actually use Y Combinator to remove the loops in the binary search as well as the stack-based algorithm, which is pretty cool. May or may not do that later, after we do that here. And then I think I want to solve a few more problems, and then after that there's other stuff I want to work on as far as like the map of what we're going to do, but one thing at a time here. So let's go ahead and, okay, so we got the results from how long this took to run this program on our, so we have our output text, and that's got 100,000 lines, right? And if we look at our program, we see the output. This is in milliseconds, so this is how many milliseconds? If you right click in a terminal, it'll copy. Just neat. So in order to get the number of seconds, you move the decimal point 1, 2, 3 positions. That is 830 seconds. Okay. That is a very long time. That is way more than 8 seconds. That's about 100 times slower than we need to be. A little over 100 times. Okay. That's real bad. How much time is that in terms of minutes? So 830.091 divided by 60 seconds gives you 13.835 minutes. That's a lot of minutes, man. It takes almost 14 minutes to execute. Okay, that's a serious amount of time. Let's maybe use a slightly different, edited, modified version here for our profiling. So let's go ahead and, where are we? It's in the desktop, right? Output. We actually want, so there's some input, right? That's the one. We're going to copy that, and then we're going to edit that to be less input. And we're going to modify this by, we're going to take off, we're going to go 10, something like 10,000 instead of 100,000. Maybe we want to do this programmatically. Watch this. You ready? We can do this programmatically. All right, you ready? This is neat. This is like one of the reasons you learn like sort of Unix scripts. So if we lsltr, we can grep for less input, right? Okay. And now if we cat this thing, we can find out how many lines we've got. Right, 100,000. Oh, really? Oh, yeah, there's one at the end. So what we're going to do is we're going to get the head of 10,000. Yep, and we're going to pipe that into the temp text. Open. Right. Now we're going to cat temp. Get the length, the number of number of lines is 10,000. Let's open with Notepad temp, and there we go. So this has got 10,000 lines now. There's one extra line here, so that's 9,000 something something, and then it's 1, 2, 3, 4. That's about 10. This should be the right number, because one of these lines is this first line. The other, there's two extra lines beyond to make it 10,000. There's the one at the top, and then the one at the bottom. So now this is 9,998. Done. And we can, we'll just remove less input. We'll do a move temp to what less input. And there we go. Ta-da. Ta-da. Got now 10,000 lines to work with. So let's go ahead and close this. Let's use less input path. Now we run this program and see what we get. Now, in theory, we made about a 10 times smaller program. So before we had, what is this, 8? Yeah, 8, this thing. Hold on. This, which became 1, 2, 3, this. Now this should take 83 seconds. Right? About a minute and a half. Maybe we could reduce this further to 1,000. So it takes 8 seconds. Let's do that. I think that's a good idea. Yeah, take it back. We want to say less input, right? So we want to cat less input. We're going to say head 1,000, and then we're going to pipe that into temp, and then we're going to move temp to less input to rename. All right, now we can Notepad less input. Now this one, we still have an extra line. We can get rid of 1, and now it's 998 rather than 10,000. Okay, let's try that. That should be fine now. Now this should take 8 seconds, just about, in theory. We'll find out, we'll see how long it actually takes. Just double check that we're live. Everything looks okay. Okay, that took 10 seconds. All right. So we can get a much better sense. I think running this program every 10 seconds rather than waiting 2 minutes to get our results. I think every 10 seconds is a good idea. So we can even go further, smaller, but that's kind of the problem, is that our program is extremely inefficient. Like, I don't know what it's doing, but it's whatever it is that's doing, it's taking a very long time. So we can go ahead and start profiling like piece by piece. So this do sequence, this is going to go through 998 loops. What we can do is just get how much time does how much time does it take to execute this routine. So this is like the key routine, right? Bigger is greater. This is what the problem actually asks for. But probably this routine is taking a really long time. It looks like it's not actually running it in linear time, because that's actually what I want to determine. So linear time, I mean these I realize it's string manipulation that we're doing. Maybe that's why, because strings are not mutable, so that could be part of the problem. But we're definitely doing, it's only 100 characters per execution, so it should be, this should be pretty fast, really. If it's linear time, that means we're some small constant multiple of about, with 100 characters by thousands, 100,000 like operations, which is not really a lot for a computer, even for a laptop like my own. So let's go ahead and let's just say T1, and we'll call this let yes, and then we want to print line calculate the time here. Let's see what we get here. So if we have T1 and then we take the difference between that and T1 after executing this line, it should give us timestamps. Did it work? Okay, wow. Really? You're kidding. What? Is that because this is done lazily? That doesn't make a lot of sense. Really? What? That's so strange. Huh? That's making no sense to me. This says basically all these operations took like a millisecond each. Every one of these took like less than a millisecond, which actually would make some sense. That's blindingly fast. But how did this take, right? If you take all these numbers and add them up, it doesn't come up to 10,000. It's like less than 100. It's like less than 1,000. Right? They're not even all one. What? How does that happen? Maybe I can do each of these one by one. I feel like maybe it's because of this is like not blocking. This could be like scheduled right after. I think, is it due? If I put a due in there, maybe that'll give me a better read. It could just be an error in terms of like the sequencing here. We'll see. We shall see. No. Really strange. What? So where's the time? Where's the time? Where's the cost? Where's that happening? Where's the cost? Maybe it's here? No, I mean I can't do anything about that, right? The actually reading things in and spitting things out, that would suck. If that's where it's, I mean, that can't be right. I mean, I could do this in a few different spots. Like maybe this is what I should do. Maybe this is better. So here we would see after reading this would be like, let's do it this way. So we'll just, after each line, we'll just print a timestamp. Try that, see how that goes. Alright, so this reads in a character, prints the timestamp, how many seconds in we are so far after each of these. Okay, so about 10,000 is what we expect. So, wow. How many milliseconds per each of these? 1, 2, 3. They all kind of happen at the same time, huh? Interesting. So it seems like it's actually all three of these kind of execute at the same time. So really you could just put the one line at the bottom and that'll give you an idea. I don't really know what the meaning of that is exactly, but that'll give you a vague idea. So this was 1 millisecond, this was 10 milliseconds, this was 8, this was 10, this was 14 milliseconds. Let's see, it's 14 milliseconds times 1,000. Yeah, I guess that makes sense. So it's only a few milliseconds per execution here, but it needs to be faster, you know, because if you do this, you do 14 milliseconds times 100,000, that's 1,400 seconds, which is a lot of time. 23 minutes. Actually, it's even worse. We had 800 milliseconds, or 800 seconds. I don't know. No, it's even, yeah, okay, 13 minutes. No, excuse me, it was 8,000. 8,300, right? Is that right? Where were we? I forgot what the number was. It was I think it was 80,000. Yeah, it was 80,000. Or 800,000 milliseconds. It was a lot. It was a lot. It was, I think it was 830 seconds. Was how much that took for 100,000. So 100 times what this is taken here. Yeah, it's about right. It's about 14 minutes. So anyway, what we want is 8 seconds, right? So what's 8,000 milliseconds divided by 100,000 queries? We want this to take not even a fraction of a millisecond per execution. You gotta be kidding me. Serious? 0.08. 14 divided by 0.08. 175. Gotta make our code way faster. What? Uh-oh. Oh my goodness. So yeah, it's just this. This is just really slow as it's written. But why though? Why is it so slow? Huh. Oh man. We're trying to get to like literally less than a millisecond per. Shucks. 1,000 milliseconds is 1 second, right? If it takes a millisecond per execution, we're still woefully behind. We need to get 8 seconds. That would be 100 seconds Holy smokes. How is this even possible? Well, you know what? I betcha. You know what I think? I have an idea. I think that our algorithm is not nearly as efficient as it should be. Yeah, you know what I think? I think our algorithm is not as efficient as it should be. We want to, if we look at this input, I think the problem, I betcha, if we use 100 characters, how many characters is this? Down here it says, right, 98. Yeah. All right, let's do this. Let's take this, because it should be the same thing every time. Let's copy this a whole bunch of times. And let's make, let's copy this a whole bunch of times. And let's make a thing. How much do we want? We probably want, let's do, well, in theory, this should be the same thing every time, I guess. I guess it really, I don't want to do this. I kind of want, like, say like 1,000 lines. Let me see if I can do this. I want to get, I don't know if Linux has like a random integer. I was going to say I can write a bash script to generate, not bash, like a bash one-liner to generate 1,000 lines of 100 characters, each with a random ASCII character from A to Z. I could write a small Python script to do that quickly. I was kind of hoping to write like, yeah, I could do that. Let's open up this guy here. Actually, no, we'll do it here. This should be fun. This should be interesting. So, and we'll pipe it. Okay, I have an idea. So where are we? Desktop. All right, we're gonna get bash here, and then we're gonna write a quick Python script. I can have Python, right? Let me just double check. Where is it? Is this Python? Hello? You alive? Is everything okay? Hello? Oh. Okay. Is everything okay? You okay, bud? Uh-oh. I don't know what happened. Right. Can we do Python here? Python.exe? Okay. What version are we looking at here? Oh, 3.7. Cool. Alright, fine. Okay, we'll just do it right from here then. So, we want random library in Python. I don't remember that off the top of my head. Python random, module, random. We just want rand. Keep it real simple. Just rand range. Rand int is what we want. So random, rand int. Alright. I don't really like writing scripts like off the top of my head. But yeah, let's do import random, and we're gonna say for I guess we'll say it's not gonna be list comprehension. It's gonna be I guess x in range. We said 1,000. For x in range, we want to get a. This will be a list comprehension. We're going to print a join of a whole boatload of these characters, which are going to be x for x in. It's going to be rand int, 100 of these, range of 100, and we want random dot, what do we say, rand int? Yeah, rand int of A to B, which is going to be 0 to, what is this? Yes. And no, it's going to be between A as an integer and B and Z as an integer, and we're going to convert that to a character. See, Python scripts are like super fast to write. And we're going to call that, put that desktop, we're going to say gen vals, gen input. And we're going to call that a Python script. Alright, save that bad boy. And we're going to Python, Python gen in, hold on, what? Oh, because I'm in the wrong spot. Python, no. Gen input, this should be python.exe. And no. Oh, it's Python 3. Oh, come on, man. Invalid literal with base A. Is this maybe, oh, I know why. I think I know what the issue is. Not int, it's ord. There we go. Okay, that's what we want. So we're going to do that, and we're going to pipe that to, now I don't know if I can do this in PowerShell, but we're going to pipe that to temp. And now we're going to explore again and find temp, TMP, refresh this here. Is there a, here it is. And let's move this to test CLJ. Actually, no, it doesn't really matter. We'll just leave that where it is. It's fine. Yeah. That's fine. Move temp to more input. Cool, got it. All right, now let's go back to CLJ test. Okay. Okay, where's, it's test CLJ, right? Yeah. Okay, and now we want to print in. Yeah. Oh, cool, I can follow the link. Neat. What I want is more input. Okay, now let's run this program. Now what I expect, the reason we're doing all this is, we can close this now, served its purpose. Yeah, wouldn't that be nice if we could write that in one line? And it's like 3 lines of Python, but it would have been nice if we could do that one line on the Unix, in the command shell. That would have been really nice to do. But the reason why we did this is with this special test case, we want to see if when we run this, these will be roughly 10 milliseconds apart. That's kind of what we're expecting. We're kind of expecting basically this algorithm to run very poorly on, like, the more characters we've got, the more poorly it runs. I'm expecting it to be like quadratic time, and that's why it's taking a very long time. And it probably has something to do with like string concatenation that we're doing. But I just want to verify that by running this on a lot of input that's sort of bad input, so to speak. Not bad input, but input that would sort of show us that result, that would give us that result, where it just takes, each execution takes about a few milliseconds. Wait, really? No. Oh no, there's question marks in there. Oh please. Why are there question marks in there? Wait, why? What do you mean? Don't need 3 of these open also. Where is... Why are there question marks in here? There's no question marks in there. What's the issue? For this input string, number format exception. These are all just characters. What is going on? Oh, I know why. Duh. Forgot. I'm supposed to have 1,000. That's my mistake. It's like, what's going on here, man? No, really? Still issues? Please. One zero zero zero. Really? What's the problem though? What do you mean? What do you mean? Try again. We go again. We go again. No, it doesn't even get that far. Really, can't do 1,000? Why this though? Why this though? What do you mean? What's the issue? It might, I don't know. Sometimes line again gets kind of messed up. Not line again, but I don't know what it is that's messed up here. But sometimes things don't work quite as expected. Shoot. Number format exception. What does that mean? Why though? What? What? Input string. I do not understand. Why would this be a problem? Is there supposed to be... No, it's just... There's no issue here. They're all new line characters, right? Yeah, the new line character gets pushed. This has a new line character. What's wrong? What's the issue? Is this because of like Windows formatting issues? Windows versus Linux kind of issue? I don't think so. I hope not. That would suck. Shouldn't matter. I think that's what the problem is. Here we can print this. So I think the problem is wait, what? Error compiling, really? Why would it be an error compiling? And also, why is there no... Oh. I guess that would make sense. Looking for a runtime exception here, runtime error. Okay, so we get this reading 1,000. Now, that doesn't make a lot of sense to me. Why does it have question marks in front? Let's see. Never mind. This is not what I'm looking for. I'm looking for why Clojure read line. So wait for input. See if there's any information about this slurp. Buffer reader. I don't really care that much. The problem that I have is that this is not an integer. In fact, if we look at what it's reading in, it says it's got some question marks in front, which don't make no sense. Like, why would this have question marks? What the heck is going on? What the heck is going on, man? I gotta sneeze. Right. Oh, why? Like, this clearly has a new line here, right? There's definitely a new line here. Maybe it's because this is open in another file. It's causing issues. I doubt that would matter, but maybe it's it. Shouldn't matter. Yeah, what is this, man? This freaking 1,000 question mark. What is that? Why is that? What's going on? What is going on? Alright, let's take a look at read line. If I put question marks in there, what happens? That is so strange. Do I get more question marks if we do this? That is the strangest thing. Oh, look at that. Wow. What the heck? What is that? What is that? What am I looking at? Huh? What the heck am I looking at? What? So this is no problem, but this, it just creates these spaces. What? Is that because of my Python script? I certainly hope not. Oh my goodness. This is crazy. This is crazy. I think I know what the problem is. I think I know what the problem is. You know, I know what to do. I know what to do. Yeah, okay. How do we rename this? More input? Alright. Okay. Alright. If we save it with Notepad++, does it work properly? What happens if we do this? Same compiler error. Dude, that is so weird. Why though? There's no extra characters here. What do you mean? If I delete this and I type 1,000, this will suddenly work properly, no? I'm completely just, I'm blown away, man. I don't know what's happening. Not seen this before. What? If I put more characters in front, right? If I do this, what the heck is going on? I have no idea. What if I make a new one XYZ test.txt on the desktop? My freaking brain, man, I can't handle it. This, what? So it's hand typed. It works out fine, but if it's from Python, it doesn't work. Come on, man. What do you mean? What do you mean? You're kidding. What? That test it. What is going on? Oh my goodness. Wow. Alright, let's get rid of this one. More input. Ah, that's not good. That's not good. What are we looking for? We want Python executable, and we want gen input Python. I think I have an idea. I think I have an idea. Should be all types. I think what the problem is we just need this. think you can do this with Python, right? Make this a string. I mean, it's going to be a string anyway, but we want to get this new line character in here. All right, how about that? Invalid syntax. Really? What? Oh. Not sure how that happened. Oh, okay, that works. Sweet. All right, let's try that. Okay, and then lines. Okay, let's go. More input, right? Okay. Same compilation error. I do. What is going on, man? I can't deal with it. I can't take it. It's not working. No. No! Come on. What is happening? This is the problem with using oh, you gotta be kidding me. What is this? What? Oh. This is the problem with, I don't know what the problem is. I don't even know what's going on. I feel tricked. I've been tricked. Why is this happening? What the heck is this? You see this? What is going on? What in the Sam Hill is going on here? That does not make any sense. Can I not use this to? I don't know, man. What if I copy this whole thing and then I make a new file and I paste and I save this as test. I don't think it's gonna work. I don't know what's wrong, but something's not right. Something is not right here. Oh no, there it goes. Huh. Oh. Alright. Well, I think it had something to do with Windows. Yeah, I think that might be the problem. I think I figured out what the issue is. Alright, let's get rid of test. Yeah, I think I know what the problem is. You gotta be kidding me, man. You gotta be kidding me. Yeah, I think I figured it out. It's carriage returns. I think it's this one. It's the one you need. And then we also need more input. And let's go ahead and execute this. And then now let's try again. And it's more input. First test is this. Let's hold on to this, actually. Now this one, oh. I mean, okay. Okay. What? No, but this one doesn't work. It doesn't open these files correctly. That's so strange. That's so strange. Maybe it's the, it's not the, no, it's not, Let's do this. Delete this. Set this to this guy. Try again. And this time, I think the carriage return goes here. No, it's RN. That's correct, right the first time. RN. I don't think it matters. I don't know. So odd. Okay. And what do we want now? Line run, I think, right? Okay, let's try that. Alright. Oh my goodness, what is going on? This is so bizarre. I do not understand at all. It's gotta be some Windows thing. I wonder if I ran it from the bash. That's so weird, man. I don't know what is going on. Wild, man. Wild. Alright. Delete that. Let's try it here then. I do not know what's happening. Python. Maybe it's the python.exe. Is that the issue? Gen input. And we'll say more input. Yeah, it's fine. That works out fine. Yeah, I got carriage returns all over the place. You know? It's all well and good. Not sure if I need another carriage return there. Oh, no, it works fine. I guess it just has something to do with running this in PowerShell. It's so strange. But yeah, okay, well, that took a really long time to just confirm what I thought was the truth. Alright, whatever. It's whatever. So, anyway, yeah, each of these. Now the last line, obviously, we ignore. Don't care about the last line. So it doesn't have any characters in it. But all of these, it took at least like 10, 11, 12, 13 milliseconds. 25 milliseconds, 43, 60, 12, 17, 7, 10. Yeah, so this seems to be the problem is that when you get these long strings, for whatever reason, my algorithm takes a much longer time to process them. So now the question is why? Simple counting sort, get swap character. Okay. What are we thinking here? How much time do we have? 8 minutes or so. Simple counting sort, get swap character, recurring pop stack, stack iteration. I don't know how to make this faster, you know? I really don't know. It's like, here's a question. If I took, I don't know, man. I'm wondering if like I took, I made one of these, excuse me, made one of these lines very long and measured it, what I would see. Could try that. Could try that. Let's just take like a whole bunch of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like this. And let's save this as just 7'2". I don't know, it doesn't really matter what the name is. And let's say alright, let's try that. Let's try this here. 44 milliseconds. We made it about 10 times longer. It took 44 milliseconds. I don't know, man. Don't know. Well, I have an idea. At least what we can do is like after each change we can see, you can profile to see how long it takes. A 1,000 of these takes 10 seconds. 20 seconds. 18, yeah, 20 seconds. Okay. So, what am I doing here? Shucks. I have this counting sort. We can use, we can test this. Right, that took about 18 seconds. Let's see what happens if we Change this to just a regular sort. If we actually get a speed boost doing that or not using counting sort. I am curious. Oh, okay. That's pretty significant speed boost. Yeah, 5 seconds we shaved off by going from, alright, that's good to know. Okay. Cool. Let's try again. That's kind of neat. We can at least get a gauge. We can at least get a gauge. Okay. Oh. Looks like it doesn't matter that much. Wait, what is going on? Huh? That, what? I guess it's kind of random how long it'll take. Some instances it takes 18 seconds, some instances it takes 22 seconds, sometimes it takes 23 seconds. Oh. Now it's taking 33 seconds? What's happening? Why is this taking so much time? What? Am I going crazy here? Am I missing something? Is there a reason why it's taking so much time? What the heck is happening? I am utterly confused. Looks like each time we run it, it takes another 5 seconds. What is happening? Why is that happening? What? I think we gotta end the stream here too. Holy smokes! What in the heck is going on? My program is taking longer each time I run it on the same inputs. What the heck is happening? What? Oh, that's even more confusing. What the heck is going on? That is just bizarre. Okay. You run it one time, it takes 17 seconds. Alright. I think it's because of the output file it's writing to. Okay, let's try again. See how long it takes. Expecting it to take 17 seconds again. It took 16 seconds this time. Okay. Let's try running it one more time. Yeah, so it must be because it's writing this file. Try again. 15.5. Alright, now it's going even faster each time. I don't know why that would be the case. That doesn't make any sense. Dude, what is going on? What is happening? Alright, 15.5 seconds seems about right. If we delete this, and we say, okay, let's change this to, let's use the regular sorting algorithm that's provided here. Right, just regular sort. Try that. What kind of a speed boost do we get here? It was around 15 seconds, give or take 3. Now with the counting sort, excuse me, with the regular sort, it's about the same. Don't actually get much speed boost using the sort of custom set counting sort. Actually, the custom counting sort doesn't seem to give us much more speed at all. Technically, that was a little bit faster than the extra algorithm we threw in there. Yeah, it's comparable. It's about the same. Doesn't seem to matter much. Alright, so we'll get rid of that. Don't have to worry about that, I think. Simple counting sort here. What I want to do then is close this, go up a level, and I've got this here. So let's do like 100 of these. I think that's what we want, about 100 of these. And let's also do these. Also use naked bash here. Excuse me. Python gen input, and then we'll go to what is this one? More input we're using. Should be 100. I think we put it at the top. Okay. All right. Let's try this again. Oh, okay. Okay. That's the line run here. Alright. Only about 100 of these. So the thing is, each of these is going to take about 10 milliseconds each. Some cases more, some cases less. About 10 milliseconds each. And there's about 100 of them, so we end up with about 1,000 milliseconds. Okay, that's all well and good. That's fine. It's just we need to figure out how to make this faster. Holy smokes, man. I wrote this bit with a stack. I'm wondering if I write this imperatively, like not without using, like if I write a loop, put this into a loop. I don't want to do that, but I think I don't have a choice. Otherwise, this is way too. Oh no, I think I did do that. Yeah, I did. occurring on a loop. Well, I could use a while loop, right? Oh man, this problem is taking a lot of time. All right, let me end the stream here and come back. Yeah, let's use the side effect with this. I guess use an atom, something like that. I don't know, man. I don't know how we're gonna do this. I guess we'll use some while loop for this stack. We'll figure this one out. We'll come back to it. Let me end the stream. So thank you all for watching this piece. This is trying to figure out why the code was too slow. It's really slow. This is like super slow. So we'll figure this one out. But yeah, thank you for watching, and talk to you soon.